In this video we're going to take a look at something called the arc length function. Now we're familiar already with computing the arc length of a curve on a given interval, and we get a numerical value that represents how long it is. So even if it's curving, if you could shake it and stretch it out straight and put it beside a ruler, we can see how long that curve is. Well, we're going to do something slightly different here. So here's the difference. This time we are going to have a fixed starting point, but kind of like a floating endpoint, where I'm not really going to define what the closing value would be, but instead I want to make it a function of x, to where when I get around to deciding what x I want, then I can plug that x into the function, and then it will immediately pop out what the arc length is up to that defined x value. So it looks like this. It's still written as little s as it used to be when we computed arc length. Leave a little space though, because I'm going to add something in here in just a second. It's the integral from a not up to a fixed chosen b value, but up to x, right? And so x might be here, or it might be here, or it might be here, or it might be all the way here. We don't know. It's kind of a floating value here. But the rest of the integrand looks somewhat similar. There's a square root. There's a 1 plus, right? 1 plus. But here's another fairly big change. It used to be f prime of x squared dx, but this violates a property of definite integrals here. You can't have the same variable in your limit that you have in your integrand, or that's your variable of integration. You're not allowed to do that. The reason that is because what's happening here in a definite integral is the variable in your integrand, or the variable of integration, in this case d something, needs to range from a to x. So that letter can't be x, right? Because x is the upper limit of that integration. So it just needs to be some other letter. And so we literally just pick a different letter. We just don't call it x. We'll call it, most textbooks call it t. I suppose it doesn't have to be t, but just to stay in line with all textbooks, we'll stick with the letter t as well. So same integrand, just different letter. And then now t will fluctuate between a and x as we compute this definite integral here. So what is this guy? Is it a number? Is it what is it? Well, we can compute this integral here, and then whatever that may be, we're familiar with definite integrals. We put a bracket, and then you plug in the upper limit, you plug in the lower limit, and subtract. That's the fundamental theorem of calculus. Well, we're plugging in x and we're plugging in a. A is a constant, that's a good thing, but x is a variable, so our answer would have x's in it. So what happens is that this guy generates a function of x. So this is what we call an arc length function, to where it's going to tell you arc length for sure, but you have to provide what the x is, which is in effect the ending point for your arc length. So the larger x is, then the arc length will increase as well. All right, so stay tuned. We're going to have some examples of arc length functions coming up very shortly. You can check those out in the next videos.